Hi to all the math students out there from Mrs. Marcellus and my wise friend Euclid. In this lesson, we're going to learn about changes in dimension. Today's learning objective is students will determine the effects of changing dimensions on perimeter and area by creating and analyzing models. Today's vocabulary. These are words you should already know, but I'd like to review them just in case we need a refresher. Perimeter is the distance around a closed geometric figure. Area is the number of square units needed to cover the surface of a two-dimensional figure. Some additional notes will follow the examples after we complete our investigation. Are you ready to get started, Euclid? Then let's go to our first example. In our first three examples, we're going to analyze the effect that changing the dimensions on all sides of a figure has on its perimeter. Suppose the side lengths of this parallelogram are doubled. What effect will that have on its perimeter? Parallelograms have opposite sides that are congruent, so we do know the measurements of all four sides. We can go ahead and write those numbers in, and then to find the perimeter, we will add all four sides. This gives us a total perimeter of 14 inches. The problem says that we're going to double the side lengths of the parallelogram. I'm going to sketch a new parallelogram and then multiply each side length times 2. This gives me a parallelogram with side lengths of 8 and 6 inches. When the four sides are added together, we find that the perimeter is 28. We can see that when we double the side lengths, the perimeter also doubled. 14 times 2 is 28. Let's investigate further. Suppose the side lengths of this triangle are multiplied by 4. What effect will that have on its perimeter? When we add the three sides of the triangle shown, we find that its perimeter is 27 inches. If you multiply the side lengths by 4 and sketch a new triangle, it will have side lengths of 44 and 20. The perimeter of the new triangle is 108 inches. In the previous example, when we doubled the side lengths of the figure, the perimeter also doubled. In this example, we multiplied all side lengths by 4. 27 times 4 equals 108. So the new perimeter is 4 times larger than the original perimeter. Interesting. Let's try one more example. Suppose the side lengths of this trapezoid are multiplied by 1/2. What effect will that have on its perimeter? If we add all four side lengths, we get a total perimeter of 65 inches. Then we'll multiply each side by 1/2, which is the same thing as dividing by 2. The top will become 6.5, the two slanted sides will become 7, and the bottom will become 12. When we add these together, we find that the perimeter is 32.5 inches. If we multiply the original perimeter of 65 inches by 1/2, just like we did to all the sides of the trapezoid, we do get the new perimeter of 32.5 inches. Let's put everything that we've investigated so far together in a table and see if we can determine a rule. In the first example, we found when we multiplied the sides of the parallelogram by 2, the change in perimeter was also times 2. In the second example, when we multiplied the sides of the triangle times 4, the change in perimeter was also times 4. In the third example, when we multiplied the sides of the trapezoid times 1/2, the change in perimeter was also 1/2. I think we can see there's a pattern developing here. If we multiply all sides of a geometric figure by a number, the perimeter of the new figure will be that many times larger. We can refer to the number that you multiplied by as a factor of change. Let's now take a look at the effect of changing dimensions on area. Suppose the side lengths of this rectangle are doubled. What effect will that have on its area? To find the area, we must multiply the base times the height. 5 times 4 gives us an area of 20 meters squared. If we double the side lengths of our original rectangle, our new rectangle will have side lengths of 10 meters and 8 meters. The area of the new rectangle will be 10 times 8, or 80 meters squared. We can see that finding a new area is not the same as finding a new perimeter. Instead of being 2 times larger than the original area, our new area is 4 times larger. Let's investigate further. Suppose the side lengths of this triangle are multiplied by 5. What effect will that have on its area? The area of a triangle is the base times height divided by 2. 4 times 10 is 40 meters, and when we divide that by 2, we get an area of 20 meters squared. If we multiply the side lengths of this triangle by 5, our new triangle will have a height of 20 meters and a base of 50 meters. To calculate the area, we will multiply 20 times 50, which equals 1,000. Then when we divide that by 2, we'll find the triangle has an area of 500 meters squared. To find how many times larger the second triangle is compared to the first triangle, we can divide 500 by 20. The second triangle is 25 times larger than the first triangle. Let's put what we've done with area so far into a table and see if we can determine a rule. In the first example, when we multiplied the sides of the rectangle by 2, the new rectangle had an area that was 4 times larger. In the second example, when we multiplied the sides of the triangle times 5, the new triangle had an area that was 25 times larger. When we're finding area, we work with units squared. As it turns out, 4 is actually the factor of 2 raised to the second power, or 2 squared. 25 is the factor of 5 raised to the second power, or 5 squared. If you multiply all sides of a geometric figure by a number, the area of the new figure will be that many times squared larger. So here's some additional information for your notes. If all dimensions of a figure are changed by a factor of x, you will multiply the perimeter of the original figure by that factor of x to find the perimeter of the new figure, and you will multiply the area of the original figure by that factor of x squared to find the area of the new figure. This matches up with the unit labels we use when finding perimeter and area. When working with perimeter, you use plane units, and we will multiply by the plane factor of x. When working with area, we use units squared, and we will multiply by the factor of x squared. Let's describe the change in perimeter and area for the figures shown. It appears that each side of the first trapezoid has been multiplied by 6 to get the sides of the second trapezoid. Because all the sides have been multiplied by 6, the perimeter of the second trapezoid will be 6 times greater than the perimeter of the first trapezoid. The area of the second trapezoid will be 6 squared, or 36 times greater than the first trapezoid. Let's describe the change in perimeter and area for the figures given. To get from the first figure to the second figure, we multiply the dimensions times 3. Therefore, we know that the change in perimeter from the first figure to the second figure is going to be 3 times greater. The change in area from the first figure to the second figure is going to be 3 squared, or 9 times greater. Two sizes of regular pentagon are used in a large stained glass picture of an owl. Each small pentagon has an area of 27.5 inches squared. What is the area of each large pentagon? Since these are regular pentagons, we know that all their sides are equal. 4 times 3 is 12, so that tells us the change factor is 3. We can use this information to find the area of the large pentagon. It will be 3 squared times larger than the area of the small pentagon. In other words, we will have 3 squared times 27.5. 3 squared equals 9, which gives us 9 times 27.5 for a total area of 247.5 inches squared. I think that stained glass window is gorgeous, don't you? Maybe we could have one made of the two of us together. Think that's a good idea? Well, we'll have to think about that. Anyhow, that concludes our lesson, so bye for now, math students.